Yeah, I turned it on.
Okay. So next up, we're going to be talking about the, what Jason Taylor mentioned in the keynote yesterday, which is how do we cross over, help people move between 19-inch EIA standards and open rack. And we have three sessions on that. The first is Alan Chang from Quanta is here to talk about their systems.
All right. Yeah, my name is Alan Chen, and I'm the product marketing manager for Quanta and /QCP. Right. So, like Mark was saying, I know OpenRank has been very successful, but there's also a part of the vertical cannot adapt to OpenRank due to their co-location or legacy infrastructure, right? So I want to talk about a little bit about how do we think could be helpful to the community, and then could be one of the things as an intermediate baby step for you guys to actually adapt the OCP product. So I don't know how to do it though. Yeah. Mark. Sorry. Hopefully I don't turn off everything. Sorry. Wow. See, I'm technical safe. All right, anyway. But for just a little bit brief history about what we do at KCP, right? For those of you who didn't know. So we have been involved with Facebook and OCP community for quite some time. So starting in 2009, we started working with Facebook on some of the internal projects like Wildcats and Windmill. And then starting 2012, we decided to use the brand QCT to kind of deliver those hyperscale customers product to the channel, to the enterprise, to HPC, to telco. And then we have using OpenRack and give you a little bit more derivative, different building blocks to provide a usage model that fits for their application and their usage. So that's what we kind of call the private cloud version of the OpenRack, right? And then in about 2017, 2014, the financial industry has worked with the OCP community to come up with what they call the Decathlete and the Roadrunner stacks. And on both stacks, actually, Quanta has version for both. And then we've been highly invested in our engineering resources, and then support to those efforts. And then just a little bit going forward, not related to this topic, but I think there's a lot of innovation and engineering effort we're going to continue to invest to the community, and hopefully we'll get feedback from you guys and see what you guys are looking for in terms of your specific vertical. And then I'm hoping we will be able to co-work with you and then make something happen, right? And improve the community going forward. So a little bit brief history on what we've done on the Roadrunner. So Roadrunner is an AMD based motherboard, and it's absolutely great. It's actually a great success for us too. And we have using this in about 2012 timeframe to win some financial industry businesses, and they have been loving it, right? So simple put, it's a dual socket with 24 DIMM and with plenty of expansion slots. It can fit into one U chassis, one RU chassis, or a 2 RU chassis. Really depends on what customer was looking for. The version that we created by that time was a 2 RU chassis, and then we're looking for customers who want to buy one RU at a time, and then turned out that great. But it was a great success, right? And then, as you know, Intel also have what I call the Decathlete specs, right? That particular spec is also a dual socket. By back time, it was 2600 V3, and then obviously the V4 is coming out. We gotta do a refresh. It's a 24 DIMM socket with 2 PCIe by 24 PCIe riser, and then there's obviously the OCP management cards, right? We have created so many of different protocols of OCP management cards from Intel, from Mellanox, from QLogic, and from back in Humalex. And there's a plenty of options for the financial industry people to actually choose from. So this will be the 1RU implementation. And let me see what else is good to talk about. Oh, also we have what we call the management VNCs, right? Like I know some of you people know about Facebook is they don't really use a lot of enterprise kind of VNC protocols, IPMI. But this particular motherboard does have that features with the remote KVMs and all those nice features that your enterprise customer or financial industry was expecting, right? So, and we also have the same motherboard in the 2RU form factor and leveraging the same motherboard with the different riser boards and giving a little bit more density, like in terms of the storage, in terms of the I/O options and things like that. So those products is shipping today and then will be shipped until the next generation Skylake comes over to replace. So that's about what the brief history is. What's available today in terms of IT EIA. So on the show floor today or yesterday also, right? And we actually have what we call the Carmel concept, right? This is literally taking the motherboard from Facebook's Leopard or the triplet design. It's the exact motherboard that Facebook is using as today. And then we slap it into a 19-inch chassis that Quanta has already shipping in some different configuration. And so in terms of meaning that is, it's a proven chassis with a proven power supply, proven storage backplane and all that stuff. It's in mass production mode. The only thing we did in terms of the concept is just putting that motherboard with a different connection interposer board to make it work. So how does that benefit you guys, right? You might be asking, hey, I've been buying motherboard from the big OEMs like Dell, HP, right, and so on. How does this help you? And one of the coming from a little bit from the manufacturing perspective and also from the design perspective is this particular motherboard was reviewed by very heavily by Intel. There's maybe a couple Intel folks right here during the design stage and obviously Facebook. And then the design signal integrity and everything like that, I would say is almost like perfect because as you can imagine, Facebook is deploying this in thousands of racks every single month. So they care about those details very, very, very much. And then in terms of component selections and all those details, it's very thoroughly I went through during the design validation stage. And then obviously the second one from the manufacturing perspective, you might not have known, like obviously the Dell HP, they have a lot of values in terms of the shipping their enterprise products. But there's not one single motherboard was manufacturing in this kind of quantity in any factory. For instance, like we're building this in thousands of quantity. Our operation people or workers, right, in China, they can literally not making any mistakes on producing these motherboards. Like they cannot, for instance, like you might say, oh, there's a capacitor was putting in the wrong place. There's some circuit board or connector was misguided or whatever that is. This motherboard you will not see because it was manufactured so many times. They know exactly where each component should be in that kind of manufacturing perspective. So with that all being said, if the feature, the later motherboard feature was exactly meeting your requirements, I think this could be a really good alternative and a baby step for you to actually step into the OCP world of the computing infrastructure, right? So we have a couple, also another one right here, next one, is called Monterey, right? This is also a micro server board. The code name for OCP community is called Mono Lake, right? It's a microserver board based on Intel's Xeon processor. And then what we did is we take this particular design and create a 4 SoC blade. Each one of them is independently swappable, serviceable. And then we create that as a 2RU form factor. We can fit 8 of this microserver board in there, right? So that allow you to get the really high density microserver or computing power in that form factor. And then again, it's OCP standard. The card, the board was actually mass production in a very high quantity of value. So let's kind of take a look about the overall spec, right? I think the first one is really interesting is the dimension. It's obviously EIA standard with the height, the width, and then all the racks and all that stuff, right? It fits pretty much on all the EIA racks. So our implementation is having 2 power supply, redundant, obviously, and then 4 compute blade, and the storage, small form factor drive, is all available in the front. So what this is, it's instead of having only 1 drive in what you see on the Facebook Open Rack, 1 large form factor drive in Facebook's usage, right? You get 6 small form factor drives that's available for you. And then since you have a PCI extension slot, you can actually install a RAID card from Argo and EMC to create some sort of RAID capability in this storage. And out of the 24, we even can have some NVMe capability for that, like maybe 1 or 2. Like we haven't decided which, how many we want to use, but you can actually probably have 2 NVMe by 4s. That's also available in the front of the chassis out of the 6 drive per node you have. So I think that's one of the things you can also, expecting to have like some sort of peering, caching usage application for this particular system. So this is a 2U 4-node setup. We also have a setup for 2U 2-node. If you aiming for additional expansion slots per compute node, this will be something that's a little bit more friendly to you, right? And obviously the compute density is a little bit lower, but you will still enjoy the benefit of having that particular Facebook motherboard in this particular system, right? All right, so let's look at the car Monterey, and then as you can see, right here. Okay, as you can see on the right-hand corner, that's how the tray was look like. And actually, that's the wrong picture, but that's how similar how the tray was look like, right? And then you have 4 micro Intel Xeon processor right there, and then you have a aggregated lens from analogs. So what it does is like you aggregate all the traffic, the network traffic from all those 4 SoC to a single NIC card. And then you can have a 50 gig or 225s or 100 gigs on it. And then literally just connect that connector to the POR and you can have full access to it. Obviously, you don't want to have like cables on each one of those things, right? That's really a lot of cables to massive. So these 3 concepts actually working in the same common chassis. So that's another thing I can feel really comfortable about. It's like this is the proven chassis. And with the proven motherboard and microserver board from Facebook, this will be a very reliable system that you can actually, hopefully, once I talk to you and then collect enough feedbacks to done the research and what we need to change and what we need to improve, we can actually put this into POR and then start manufacturing those with your demands. Okay? So this will be how the chassis looks like. And like we kind of designed this very modularized, right? You have power supply, everything was really hot swappable, serviceable very easily, and all the fans, all the power distribution units and all that stuff is very easy to swap out and into service. And we also have the hot swappable fans to have the redundancy and all that stuff to prevent some of the downtime that you can possibly have. Obviously, there's a lot of computing power in that system. So this is what we call the power distribution board. It's really easy service. It's already modularized, and it has been shipping in a lot of quantity. So this will be how the motherboard looks like. And as you can imagine, it's a dual socket with 16 DIMMs, and then there's a 1 OCP management slot for your networking card. And then there's additional one PCI slots that's available on the left hand side or right hand side, or whatever you want to call it, of the motherboard, right? So that's how you get your extension. So motherboard wise, Facebook was using a chipset from HP, a company called HP, and it has limited option of manageability. And Quanta also has option of using a pin-to-pin compatible chipset from the same company, and then and add it on the enterprise level of the manageability and so forth. And we already have that software using various and very widely in our product portfolios. So also that will be a change for us. So just in case you're wondering about that, how the management ability is going to work, because the Facebook motherboard we're not using the full management. And talk about monitoring a microserver board, right? This is how the microserver board was like. So it has 4 RDIMM, right, and the microserver chip, and then on the right hand side, I don't know if you can see it very clearly. There's actually an SATA, or it could be also a M.2 as your boot device and storage devices, because obviously for that compact of spaces, there's not many rooms for you to actually install and compile it. But in the front of the chassis, we actually, for this particular system, each of the microserver board actually get about 1 or 2 small form factor drives. So other than the original boot devices or storage devices on the microserver board, get additional connectivity and storage on the chassis level. So this is how kind of, in some degree, how the module was put together to a linking board or assembly board, and then getting all the signals. And as you can see on the green part, there's a there's an SAP Plus connector right there. We will demoing using the SAP Plus, and then there's future they will use the SAP Plus connector, and then to give away a higher throughput for that. How much do you have? So couple I/O options that you can see, with a RJ45 and power connector. So this is another view how the board was put together and what kind of components was using in this particular blade, and then to make it work. Right? So I'm still having a little bit of time. So is there any question I could answer for you? Yeah.
Great job, actually. Shrinking a 21-inch width to 19 inch, you added almost all the components from Facebook architecture. You added 2 power supply, 20 power bank. What you did, you get the instructor width, get the same height.
Yeah. Actually, in terms of the density of taking Monterey as one of the examples, we actually in the 2U space, right, 2OU to 2RU, we actually can only fit 8 monolith instead of 12 because the space of the power supply and all that stuff. In terms of the Carmel, the way we design this is, as you can imagine, or conventionally, like you always get the 2.1 half with motherboard, right? But the way Facebook's design was a 2U3 node is not by limitation of the space. It's by I don't want to say limitation, but it's by a choice of how they want to use their application. So they decide to use a 2U3 node, and then for thermal, for other purposes, cooling and all that. So that's how they decide to use it. So we're not on the Carmel side. We're not doing anything amazing. We'll just follow this traditional 2U design and to make sure it fits nicely, right? And then, but on the Monterey design, we actually have to give away some of the things.
So you increase it, yes.
Well, not technically, no, because the chassis is actually for the open rack it's predefined because you have to click to the bus bar, right? So there's a lot of weight. I don't want to say waste, but a lot of space was not being used.
Okay.
But in our design, it's more compact. Like everything was very nicely put together.
And what are the reasons to move from Facebook more modularized, compact power supply to what I want to use? Where here you're bringing back to the traditional server players with the power supply. What do you see that benefit?
Okay, so one of the things when we're promoting the OCP gear, right? We've already been promoting OCP gear for a couple of years ago. So one of the things we always hear from customers, they love the idea of how Facebook is promoting it and Microsoft is promoting it, and with all this innovation like concept and design and everything like that. But not everyone's building their business. Not everyone owns a business that they can actually to play around. And so for OpenRack, there's a specific infrastructure that's required, right? OpenRack. So the bus bar, someone love it, someone hate it to the gut, because someone was saying bus bar was a little bit dangerous in their environment that they'll master. So I think this is a little bit step backward to meet what the legacy people have to use, but still want to enjoy some of the innovation and the benefit I was talking about earlier, right? Like from those tier 1 hyperscale customers. So that's like, we want to create something in the middle as an intermediate solution, right? But once your business grows to a size, you might be saying, hey, I really need to build my own data center. And for the TCO perspective, I might really could have the benefit of jumping all the way to OpenRack, right?
Sorry, I have one last question.
Sure.
So you, in your architecture, you took away the bus bars and you went back to the IAC socket, AC plus. Is that how it goes?
Yeah. Any other questions? So hey, we have all this demo at our booth at I think C4, right? C4. So anyways, the show floor is right there, and then like we have technical people over there answering your questions, and if you guys were interested in that, like stop by, feel free to let us know what you think. And we haven't PR'd this, so this is obviously still a concept stage, and we'd love to get more feedback from the community and then see if we can consolidate a product line and the feature set that meeting of your needs. Okay, thank you. Yeah, exactly.